ladies and gentlemen. So today we're going to be taking a look at 7.1 permutations and combinations. This unit is all about probability, so let's recall a few things about probability that you've learned in the past. Number one, probability is found by taking the number of desired outcomes and dividing it by the total sample space. So we always have what's called probability notation attached to every problem we do, where we have capital P standing for the word probability. Inside the parentheses, we write out whatever event it is we're finding the probability of. And then it's always our desired number of outcomes, what we're wanting to happen, divided by the total number of outcomes, everything that could happen. Remember that probability falls between 0 and 1 inclusive, 0 meaning that it is impossible and 1 meaning that it is guaranteed. Probability can be written as a fraction, decimal, or percent, and unless I specify otherwise, I really don't care which method you decide to write your final answer in. The first thing we're going to learn is what's called the fundamental counting principle. So if there are n items and m sub 1 ways to choose the first item, m sub 2 ways to choose the second, and so on and so forth, then what you do is you take all your ways of choosing each of those items and you multiply them together. So for example, if we're making a yogurt parfait, and we want to figure out how many parfait choices are there. Well, we can choose between plain and vanilla yogurt. We can choose between peaches, strawberries, bananas, raspberries, or blueberries. And then we get to choose between almonds, peanuts, and walnuts. So the way that we layer our parfait, I have two options. For the yogurt, I have 5 options. And then I have 3 options. So to figure out all the different types of yogurts I can make, I'm going to take 2 times 5 times 3, because I get to choose from 1 from each of these categories, giving me a total of 30 different yogurt parfaits that I could make. Example 2, a password for a site consists of 4 digits followed by 2 letters. The letters A and Z are not used, and each digit or letter may be used more than once. How many unique passwords are possible? Well, our digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, and so there are 10 digits. So I'm going to write out 4 spaces here for our digits. And then I'm going to write out 2 spaces for our letters that we can use at the end of this password. So we have 10 options for every digit. Then the number of letters in the alphabet, but taking out A and Z would leave us with 24. Please be mindful that if you are just having a bad day or you're blanking and you don't remember how many days are in a month or how many weeks are in a year or how many letters are in the alphabet, those are always things that you can ask myself or Mr. Brasser questions on. So multiplying these all together, we get a final answer of 5,760,000 different passwords that could be made using 4 digits and 2 letters excluding A and Z. So the next thing we're going to talk about are factorials. I know it looks like an exclamation point, but really what it's referring to is starting with that first number that's listed and going in descending order all the way down to 1 and multiplying them all together. So 3 factorial is 3 times 2 times 1, giving us 6. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, giving us 720. And 9 factorial, 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is, not 8, 362,880. So you've dealt with factorials in the past, and it's not a very difficult concept, but let's talk about how factorials can be used.